Well, while I'm a little nervous to be addressing such an esteemed group, I'm really grateful that they gave me a chance to just talk about something that I think is pretty fun and exciting. My name is Matthew Harrison. Like he said, I've been at More Good Ideas for a little over 20 years now. And as I'm sure you can guess from what's on your table, I've got a new 3D printer. And so I've really been enjoying that. Mostly just been printing like Heroes, Horde, D&D stuff for my son, and obviously some project boxes. So that's been really good. I like to think of something that's relevant to what I'm talking about, and I did have to do a little bit of research, but I found out Lisa Crump, along with her husband, was co-developing some of the original technologies and patents related to FDM 3D modeling. And even though maybe her husband got a little more credit than she did, I think they were pretty cooperative in developing it. And she's gone on to be a real leader in the 3D community, and especially in the medical 3D printing community. Now she's a managing partner at Sophia Fund, really fostering women-led growth businesses. And despite, I don't know, without getting into a sidebar on the politics of patents, as these Stratasys patents were so instrumental that as they started to expire a few years ago, it's really been one of the big factors in kind of the explosion of the consumer 3D printer market. So I guess I personally am kind of glad that they expired eventually. All right, so back into LoRa. What I'm going to try and get across is what is LoRa, so we can understand that. I want you to have a little bit of background on LoRaWAN, which is a really closely related thing built on that. And then talk about Meshtastic, which is maybe a little simpler topology. And then give you some ideas on what you would want to do if you're going to try and do something like this yourself. And I've got a demo. Now, for that demo, we're going to get to it in a minute, but when we do get there, if you could try and nominate a volunteer from each of your tables, because you have a little demo device on your table, and in order to participate in the demo, it'd be great if somebody from your table was willing to download the appropriate app for your mobile device, because that's how we're going to be able to interact with it and have all of you participating in what we're doing. If you didn't get that or you lose it, you can easily just search for Meshtastic on whatever app store, and you'll be able to find it as well. So just, first of all, the name LoRa is kind of just a mashup of long range. It uses a license-free radio frequency. In Europe, it's 868, and here in the United States, it's 915. Usually, basically pretty low power. These are for low energy devices, a lot of times on batteries and things like that. But the design of the transmission is specifically to have really low bandwidth and really long range. So on that trade-off scale, it's tilted way towards the long range. Because this is a proprietary owned by Semtech, all the chips that you buy on all the different devices, there is a licensing fee to them, but they're still not that expensive. Now, LoRaWAN is, you can kind of think of it as being built on top of LoRa. It is an open standard, and it's a way of sort of managing the interactions between various LoRa nodes and communicating based on gateways and servers. And so here's a picture of kind of how the topology, a typical topology might work out. And so you've obviously got a lot of these end nodes, and then they're going to be communicating over these orange lines up to gateways. The gateway is going to have typically multiple channels, like 8 different channels, so it can communicate with 8 nodes at a time. And the gateway is going to potentially be doing some filtering, but mostly forwarding. So if nodes want to communicate with each other, the gateway can allow those connections. And then also the black lines between the gateways and the network server are going to represent some type of IP connection, whether that's Wi-Fi or wired Ethernet or even something like a mobile phone connection. So basically this allows for nodes that are potentially distributed even thousands of miles apart, because you can imagine some of those network connections could go through the internet and stuff like that. But this also obviously has some infrastructure involved. You've got to have all your nodes, but you also have to have gateways that are appropriately spaced, and you need to have some network servers with the network server software, and things have to be in place in order to be able to use this. And so there are a lot of companies who offer various levels of service for doing this. So here's a smattering. There's probably actually a lot more, but basically at some level these are going to provide some amount of the services that we were just looking at here. So some of them might provide the gateways and the network server, and all you have to do is pay them, and then you can connect your nodes up to their gateways. Others, you might have to provide your own gateways, but they'll provide all the network services that you might need to connect up to. Some of them, a lot of them in fact, have some sort of like a free tier with very limited capabilities, and then more paid ones that you can get a lot more. LoRaWAN is a great technique, and if you're doing a real professional installation, it's probably the way to go. I forgot one thing. I was going to highlight one of these in particular, which is in the bottom right, Chirp Stack. That's one that's sort of more of an open source, self-hosted thing. So you could potentially buy your own network server, run Chirp Stack on it, buy your own gateways, and set up your own completely private setup, which I think would be maybe fun. But if you don't want to go all that infrastructure, there is another way, and as for this demo, it's particularly useful because we don't have to have anything other than just the devices on your tables. And so that's going to be Meshtastic, which I'm going to look at. And basically, Meshtastic is an open source, publicly available thing. You can just go in GitHub and download the source code or the binaries. And what it's going to do is it just installs some firmware on your little LoRa device node that allows it to communicate directly with nearby nodes in a mesh network configuration. So basically, for what this kind of demo is of showing this off today, you sort of want to imagine that this room is kind of like expanded out. So if we were like, say, a wind farm, and each of your tables was a separate windmill in the wind farm, or if we were an oil field and each of you were oil rigs, and you wanted over some reasonably long distance on the order of a few kilometers, you wanted to be able to communicate with each other, then you'd be able to just send these messages around and be able to do whatever status or commands you wanted to send out. So in this picture here, kind of all these brown colored devices would represent LoRa nodes, like each of your tables would be. And then the green, like cell phone things or the PC thing, would be some kind of like a client application that would be communicating with the LoRa node. Most of the time, LoRa nodes have either very limited user interface, just a small screen and maybe a couple of buttons, or else maybe they don't have any user interface at all. And so having some kind of a client application that can connect there and allow you to interact with it in a more usable way is almost necessary, or at least really helpful. And so there's a few different ways that those can communicate, indicated by the symbols there, but Bluetooth is probably what is the most easy and what we'll probably be using today. But you could also do it over Wi-Fi or serial if your device supports that, which most of them would support serial and maybe Wi-Fi. It's important to me that I don't lose anybody in the dust and people are following what's going on. So I hope if anyone does have questions or is feeling like they're lost that you'd feel comfortable raising your hand and making sure I bring everybody along with. All right, so what nodes are available for doing this kind of thing? There's a lot of devices that you can buy in like the $15 to $50 range that are going to have different types of processors. Maybe they have a GPS on them, maybe they don't. Maybe there's other sensors that you could get hooked up, like humidity or temperature, or there's a pretty wide range of things that you can go with that. In fact, it's really easy. In fact, it's hard not to spend more on a decent antenna than on the actual device itself. Unfortunately, your tables don't have what I would consider decent antennas, but they'll probably work for this room. One of these that I'll maybe point out is the bottom right again. That's a Raspberry Pi hat that you could put on, so you can imagine that would open up some possibilities with all the computing you could do on a Raspberry Pi and still send out LoRa. And I was going to show, just so you get because these pictures show one thing, but they don't show a great sense of scale. So I have just a couple. This is the same one that's inside your little boxes on your tables, but they have other little tiny ones and bigger ones. In fact, that reminds me, I forgot an important thing, which is to plug mine in. So here's the one that I'm going to be using for the demo, and I'm just going to plug it into USB here, which is going to show up on my computer as just a serial port, because it's just got a USB to serial converter in there. When that comes on, right? Okay, very good. All right, so what is inside the boxes on your table? Like I was showing you, you've got one of those little Heltec Wi-Fi 32v3 controllers, and I've wired it up so there's a power switch on the back, and then inside we've got one digital output that's wired to the LED on the front. We've got one digital input that's wired to the switch on the front. So the switches, you can see, have an X and a check mark. And so like a lot of demos, you kind of have to use your imagination a little bit. But what I was hoping we could imagine is that for whatever you want to imagine, say you're a windmill, if your LED is on, that means that some remote system has requested something of you in the typical microcontroller hello world style of turning on an LED. And if you switch your switch, then that means that you're reporting something back to home base or something like that. Whether you're in a good state for the check mark or maybe a bad state for the X. Like I said, most LoRa nodes don't have much of an interface, and so we want to use some client software to communicate with the firmware that's on the Meshtastic node. So the firmware that's on there has a few jobs. One of the things that it's going to be doing is kind of managing this mesh network and forwarding messages from one node to the next node. So if you have a string of these, say down maybe like a pipeline, for example, you could have a situation where each node is kind of hopping the message all the way down the line, and you can get even longer communication distances as long as you're willing to let it kind of hop along. It also has the job of communicating over whatever interface, serial or Bluetooth or whatever, to a client application so that you can ask it to do things for you. And those are the apps that we were looking at right at the beginning. So what we're going to do now is kind of start into the demo phase. And so what the next steps are for the demo for you to participate in it is we want to have you figure out how to get your mobile client app to connect to your table node. So if you haven't already fiddled with it, you should turn that on. And then here's kind of some instructions that it's not 100% every single step, but I think it's kind of the key steps that you need to take, because once you start up your Meshtastic app, it'll probably have some sort of welcome screen and it may ask you for some permission to use your Bluetooth. But once you get through those, you're going to try and be selecting your table's node. So each table's node has its number written on it. It's T-number, and so that stands for table 1 or table 2. And so you should try and find yours in the list. So where it has this list of T-whatever numbers, find yours and connect to yours.
I had the power on.
You had to do what?
Turn the power on.
Yes, you do have to turn the power on. Sorry if I wasn't clear on that. You can tell if it's on because the screen should come on.
We're turning it off and turning it back on because we don't see it.
Okay. I did test this out with all 15, and it seemed like I was able to search through them all, but we're a little bit more spread out here, so maybe that makes a difference. I'm just kind of trying to look and see if people seem to... Oh, I was also going to kind of apologize. I thought there was only 15 tables, but I found there's a couple more in the back that I didn't know about. So maybe you can look over the shoulder of other tables.
Norm is sniffing all your data with his clock.
Yeah, apparently Norm is going crazy with this. I don't know what he's doing. I didn't know he was going to do that, but that's fine.
So somebody else is talking to us.
Right. So if you guys are starting to get connected, then what you can do is go to the messages list, and for some reason they name it differently in the two apps. In the Android app, the main channel is called Long Fast, and on the iOS app, the main channel is called Primary Channel. I think fundamentally in Meshtastic lingo, that'd be called the default channel, but whatever. They have different things. So if you are successful in connecting to your node, you can go over there and you can type a message, and it'll get sent out to all of the other nodes that are in range. So you'll start seeing kind of a chat show up in your list. All right, so all right, so if anyone is still struggling to get connected, could you raise your hand? What's the trouble with? It's just failing to connect. The only sort of troubleshooting I can offer is sometimes if it's tried to connect before and failed, it'll get into a state where it doesn't work. And so you might need to go into your Bluetooth and just forget that connection and try again.
Yeah, I tried that.
Okay. Well, that is because I am running, so what I want, there's not a lot of LabVIEW in this presentation, and so maybe I'll apologize for that, but I wanted to have non-zero amount of LabVIEW. And so the way that this demo is configured is I've got some LabVIEW code here that's talking through my serial connection to this demo LoRa device. And then this is broadcasting out some commands to all of your devices, and you can see it sort of stepping through and trying to connect. Apparently, I'm failing to connect to a lot of them, but I'm trying to go through one at a time. It takes about 10 seconds to open the serial connection, send the command, let the remote node process it, send back some kind of a response, and acknowledge that. So it's going through pretty slowly, and I'll just kind of show you the LabVIEW code is fairly straightforward and simple. All I'm doing is I'm using there's a CLI application for Meshtastic, and so I'm just sending CLI commands to that here, so you can kind of see how that command would be getting constructed. And all it's doing is it's saying, in this one here, I'm just basically picking a random value to whether I'm going to turn your light on or off. So you might see your lights come on and then go off, and that would represent some central command system that's requesting something from all of the different nodes. And then if you are to, say, change the state of your switch, it takes a long time for me to recognize that you've changed it. It's not going to, if you switch it back and forth, it'll probably miss it for sure. But if you change that state, then you should be able to look up here and see, it looks like some of the nodes I've been able to recognize, like table 1 apparently has theirs in the check position. And table 5 apparently has theirs in the X, or the bad position. So I'm getting kind of feedback on how things are going out there in the world. All right, table 2, 3, and 4 are having problems. Are you having problems?
We're communicating.
We're doing fine.
I'm not 100% sure. I think it might be Bluetooth problems, but. All right, well, hopefully we're getting at least enough tables that we can kind of tell what's going on. All right, they're still slowly we're adding a few more as people resolve their issues. Have people been able to send messages to each other? Have you?
That's why we've kind of started ignoring you.
Okay. I also wanted to point out, you might see in your little chat something that shows up like sequence 1 or sequence 200 or something like that. I'm not 100% sure if that's going to get through to your nodes. I was getting it in my little demo device, but I left one of these in my car out in the parking deck that was configured in what they call like a range test mode. And so all it does is it just sends out a numbered sequence of messages over and over again. I've set it to do it, I think, every 1 minute. I was hoping to be able to show that it actually can go for some distance. So if you see those coming by, that means that you're getting a message from my car across the street over behind us. And so that was kind of cool. I think that the thing that is, to me, really interesting about this whole LoRa technology in general is that you can have sort of an off-grid network that you don't need to rely on any other infrastructure. You can just talk over pretty long distances. From what I've been experimenting with, it does struggle with things that block its way, like buildings and walls. So I was happy that we were able to get through all these walls. So if you can get something up on like a rooftop or anywhere just a little bit higher, then that's a lot better. I'm going to just leave this running, but I want to switch back to the presentation for a little bit more.
How much data can you typically get from a node?
Well, not very much is the short answer. I think that a single message is limited to, I want to say, 255 characters at the most. And if you look on your nodes, you can kind of see like what the saturation of the channel is. I don't quite know how to quantify it, just other than to say it's really small. You're not going to want to be sending photos this way, probably. But some, short status messages every few minutes is sort of typical usage. So anyway, I have some ideas for what could be done with this in the future. I think under the hood, like what I'm doing here is I'm just using their built-in CLI command, so I'm just sending things that they're allowing you to do. But under the hood, it's all just a bunch of protobufs. And it would be fun, I think, to learn how to communicate through those fundamental protobufs, sort of take a little bit lower level control of what's going on there. That would probably be a lot faster. I don't know exactly how much, but with what we're doing now, it's taking 10-ish seconds to do a communication. I'll bet we could get that down to less than 1 probably if we were doing it that other way. Now, the other thing that I think is really fun is that fundamentally, I mean, I am communicating here through the USB because it's easier, but there's just a built-in UART on this chip. So if I had any serial port, I could connect to this and I could just send commands over serial and get them rebroadcast out. So fundamentally, I could be anything, right? I could be a Creo, I could be a Linux box, I could be whatever. As long as I have a serial port, I could be doing an arbitrary amount of complex acquisitions and processing, and then have the ability to just, by sending serial messages, broadcast that out over a wide range. I think that would be pretty exciting. Another way you could handle that is Meshtastic itself is open source and allows for add-on modules. And so you could potentially code a module to implement some kind of additional functionality on the unit itself. I didn't put this in the slide, but you also could just write your own firmware, right? You don't have to rely on Meshtastic. You could write your own code in C or whatever you wanted to and embed it on the controller, and then just do your own thing. Honestly, this went a little faster than I thought it would, but if there are any questions, I'd love to talk about it some more. Okay, well, that's kind of what I thought. I was hoping that people would, I think maybe nervously I just kept talking, but I was wanting you to have a chance to play with that. And well, I wanted you to be able to see it.
And nothing else.
You can just put your thumb over it. All right.
What's the range?
So I didn't get anywhere near this, but there is a world record for it, 1,336 kilometers. I think, it was obviously on the lowest bandwidth setting under ideal conditions. I think they did it like over water or something like that. So that's not typical, but I would say typical is in the city where I am, I was testing it around, I would say maybe a kilometer was reasonable. If you were able to get nice situated antennas on tops of buildings, you could probably get 3 or 4 kilometers, I think. Was there a question over here? Yeah?
So one of the things that's really interesting about the experiment that you've run here is actually showcasing a great example of what kind of not to do with what we've got the mesh, because it's everybody all at once trying to transmit at the same time. And as you had mentioned earlier, this is intended for periodic, infrequent, and far apart kind of communication. So it's absolute. That's. I mean, we're staring at it here, right? It's complete. The channel on which everybody's communicating is completely congested because there's this effort for continuous communication. But I think for Meshtastic and for all of us that are interested in possibly using it, we have to recognize that is that limitation. It's not supposed to be the continuous, and it shouldn't be a bunch of nodes all in close proximity trying to transmit at the same time because of that limited bandwidth. But that's what enables the long distance and the low power. But I think that's a great experiment that we've got. Like if we were all to separate and only turn one on at a time, it would work great. But because we're all contesting for the same spectrum right now, that's where a lot of the inability. So it's really neat.
That's true, and I think we're also having some issues with too many Bluetooth connections trying to get made right next to each other or something like that. Yeah.
So if I'm doing this, in a limited power situation, and I've got a solar. How big a solar cell do I need? I guess sitting next to my device to power it forever and have it update its status, once every 10 minutes or some very low frequency like that.
Well, I mean, there's a lot of tricks that can be played. If you just sort of take these Meshtastic units out of the box, my experience is they'll last. Well, I guess I didn't try with solar, but just on a typical battery, they would last like a day. But if you were playing all the tricks, these are ESP32 based. There's another like NRF based chip that is maybe a tenth or a fifth to the tenth of the power consumption. So those would be a lot better if you were really going to try and do something that was completely out there and only solar powered. You can also, Meshtastic itself might not work so great for this, but if you wanted to take more control, you can put them into deep sleep mode and just only wake them up every 10 minutes, and you can get it to last for weeks or months if you do something like that. Or if you've got the solar forever, then probably. Any other questions or problems? I guess one of the things I was just going to tell you is I do need to save numbers 1 through 6 for another presentation of this that I'm going to do back home, but numbers 7 through 15 are fair game if anybody wants to take them and check out what, in fact, I don't know if you guys have already done this trying to fiddle around, but you can click on the little map button on your client and you can sort of see what nodes are around. You'll obviously see a huge cluster right here, but there's actually a lot of other nodes around in the Boulder area. One of the things that I was going to kind of point out, if you're looking through the little node list that you'll see there, it's pretty, I guess, open-minded about what it counts as a connection. If it has ever seen a message from anyone, it'll kind of show up in your available nodes list.
144 hours ago?
144 hours. I mean, that one was probably from like back in Utah, right? It's 500 miles away, because it doesn't know when it's going to get another message from that node. And so it just figures, well, maybe it'll talk again later.
Do the radios support any form of encryption, security, restricted access? What's built into the radios?
That is a great question. I probably should have mentioned that. So the way it works is the standard channel or the default channel, well, all channels are encrypted. But the default channel and the standard channel are encrypted with a key that everyone knows. So effectively, it's not really encrypted. But if you create any other channels, if you create, like some of you might see a channel called GPIO, and that's the channel that I'm using to turn people's lights on and read back their switches. But you could create any channel that you wanted. And when you create a channel, it gets a new key. And so only people who have your key will be able to read that. And you can create like a QR code, or you can just send them the text string. And then they can add that channel to their device. And then only those two, or however many you've shared it with, are going to be able to receive the message. It can still hop from node to node to node to node, but none of the intermediate nodes will be able to decrypt the message. They'll only be able to just forward it on. Does that answer your question? I read it, but I don't remember now. Sorry. Yeah?
Can you provide the 3D model so we can print these?
Oh, these? Yes. I didn't think you'd want that, but yeah, I could post that. Sure. You're talking about just like the cases? Okay, yeah. Yeah, question here in front. Wherever the mic is, there's a question here in front.
What 3D printer are you using?
Oh, I've got the Prusa Mark IV.
Oh, okay.
It's a filament printer, obviously, I guess. But. All right. Are there any other questions?
So, did I understand right? There is an acknowledgement that the message reached the address it should go to?
There's an acknowledgement that the message reached someone. It's not exactly a reply from your, generally speaking, the nodes aren't addressing another node. You can actually address another node, but the way that works is just by sending it out to all the nodes, and then if it wasn't to them, they don't show it. So if the only real acknowledgement you have is that your node was received by someone, and not necessarily where you wanted it to go, I guess. All right. Well, I don't know. Maybe I'll just wrap up a couple minutes early here, and unless there's more questions. Yeah, we can let you just play with that for a little bit. In fact, that is kind of one of the use cases is for people who are hiking or whatever out in the mountains. They could bring a couple of these with them and their buddies, and there are ways that you can have it buzz when it gets a message. You know, some of those modules I was talking about will do that sort of stuff.
I have a question.
Yeah, go ahead.
It's not clear from this Is it on? Okay. It's not clear from this interface. Can I send a message to a specific table?
Yeah, you can actually. In order to do that, you have to, I'm trying to remember what the interface is, but I forget where you have to click, but I think you have to click on one of the other nodes in the interface and then send a message to them. All right, well, maybe I'll just go ahead and wrap up and let you guys have a chance to play with that for a little bit then.